So I'm Taz. I'm going to be giving a talk on feedback. Okay, so I'm going to be giving a talk on the WebPack build tool. I've been using it at HIGHLINE, a startup that I'm CTO of for quite a while now. And we've been using quite a few other technologies. And it's actually the first company I've worked for in 15 years of doing JavaScript that we've actually chosen all the technologies properly. There isn't a single technology in our stack that I'm like, why did we choose this? Why did we go with this? Everything we've been very productive on, and everything has been very useful. So I'm going to be sharing one of those with you today, which is WebPack. I mean, I'm the CTO, so I get to pick the technologies, so I'm packing myself into that. Okay, to start off, yes, I'm presenting in Vim. Yes. I'd like to start off with a history of build tools, sort of give us some context as to where we're coming from and how WebPack solves problems. So first and foremost, way back in the day, we used to inline our JavaScript directly in the HTML, so something like this. It's great for small amounts of JavaScript, and you can only make one web request and you can get everything you need, which is great for mobile. We then moved on to unobtrusive JavaScript, which was basically you put your JavaScript in a separate file and you reference that from your HTML. This separates the page structure from the dynamic logic of JavaScript. You can easily build all your different files by simple command line instruction. Build tools basically stayed like this for a very long time. I mean, back when I started JavaScript, it was basically this. From there I moved onto the Rails asset pipeline, and it was sort of the first mainstream JavaScript build tool that I used. Back when it was coming out, I actually contributed a bit to it, so you might see my name if you could blame it. And I'll take the blame. You can come blame me after, guys. It gave you the ability to write JavaScript in multiple files and bind them together using require syntax. That was pretty new for the time. To transform files based on the extension. So .js.es6 will transform ES2015 into just plain old simple JavaScript. .js.ts.erb will then execute ERB as a template, create TypeScript out of that, and then finally convert that TypeScript into plain old JavaScript. So this was pretty revolutionary for the time, being able to just chain transformations on top of each other. You can combine these JavaScript files into one file and then serve that one file out to your client. Rails will concatenate them all based on your required definitions. And finally, you can add checksums to these files in order to bust caches. So here we have application dash big checksum. We have the application CSS with a checksum and images as well also have the checksum. So basically what this will do is if you're loading this, the browser will see it as a different file that doesn't have any caching on it and will re-download that file. So all of these things were pretty new and introduced by the Rails asset pipeline when it first came out. Since then, we've had something called asynchronous module definition, or AMD for short. So what this was, gives you the ability to separate your JavaScript into modules. So Rails gave you the ability to separate your JavaScript into files. This gave a more modular approach. You're defining module by module, and generally speaking, they're smaller than files. Modules will define their dependencies, and then AMD will load in the dependencies for each module on demand. So basically, the dependency graph, for example, require JS. So here, this is the basic syntax. Define requires on AB, module A, module B, and in your callback, you'll pass in module A and module B, and you can do whatever you want with that. So from there, we move on to Browserify. It embraces the NPM ecosystem for packaging JavaScript applications. So it's no more of the what's Bower? It's a package manager. Install with NPM. What's NPM? It's a package manager. You can install it with brew. What's brew? You get the idea here. So we can basically cut out one of those steps. We can cut out Bower and just use NPM. Everyone publishes on NPM anyway, so it was really a good thing for Browserify. They use common JS modules. So once again, everything's modularized, but it's modularized using the common JS syntax opposed to the AMD syntax. It doesn't produce globals, so this was something kind of new for Browserify. Like the way that it packages and loads all your code it does it in a way that doesn't introduce any additional globals other than what Browserify needs to operate. So that helps mitigate security attacks, XSS attacks, and so on. Browserify will combine these modules in a single JavaScript file. I mean, there's other ways Browserify can do things, but this is the default. And that JavaScript file can be minified and transformed appropriately. Cool. So what are the problems with all of these different approaches, and how does WebPack fit in? So first of all, the problem with inline JavaScript. It's great up to a certain amount of JavaScript. I recommend inlining up to 12 kilobytes, which works out to around 8 TCP packets of JavaScript. I mean, small enough for mobile, small enough in general. Anything more than that, you should probably chunk it out into different files. You have to retransfer and reparse all of the JavaScript on reload. So every time you reload that page, if you grab it again from the server, the JavaScript engine has to reparse everything, recompile everything, and redo everything for every single time you reload that page, which is not efficient at all. So what are the problems with single file-based build tools? This is Rails Asset Pipeline, Browserify, anything that produces a single file. Lots of data is transferred over the wire. So I've worked at companies where they have 3 megs of JavaScript, and that's probably small from what some people in this room are used to. Startup time lag, obviously transferring that over takes a lot of time. It needs to parse and compile it. There was actually the Chakra team that works on the JavaScript engine i10 and 11. They did some analysis on JavaScript startup time parsing, and some JavaScript apps, like 50% of your code is executing on startup. If you're using jQuery, adding on all those jQuery plugins is taking up your startup times. It needs to be parsed, compiled, executed. That's taking up time that your front end is experiencing. It may not be such a big deal on a desktop, but on mobile, it's noticeable. And every single time you change that file, that 3 meg file or 10 meg file or whatever, you have to re-download it. So that eats data. So what's the problem with AMD? Lots of web requests. So the thing about mobile, you want to optimize for the least number of web requests because web requests are expensive on mobile. So RequireJS has some optimizations for lessening the number of web requests, but there's still quite a few. The syntax is annoying. You need to indent all your code in the callback, which creates code pyramids. Requiring lots of dependencies get messy. So can you guys spot the bug in this code? So define A, B, C, D, E, F, G, H. Only missing the F, right? That's very annoying. So try doing that at scale. It's very, very irritating very quickly. So what's the WebPack way? All assets are loaded inline via JavaScript. So CSS is inline in JavaScript. Images are inline in JavaScript. JavaScript is inline in JavaScript. Give you an inception joke here. You can only load, so WebPack only loads the minimum assets required in order to serve the page. It does that via code splitting, which I'll talk about in a bit. It can asynchronously load new assets as required, so it's kind of like AMD in that way. You define your JavaScript in modules. You can do this using CommonJS or AMD, but why would you want to use AMD? Because CommonJS is so much better. You can use NPM as a package manager. It doesn't introduce globals, so just like Browserify in that way. You transform your assets, so TypeScript can be transformed into ES5, so yeah, ES 2015, JSX, TypeScript, etc. You can define your transforms globally or per dependency. So that's a big upgrade over Browserify. Similar to Rails, how you can do that on the file extension itself. You can do it for every single file if you so desire, or you can do it globally. There's a plethora of tools and optimizers that are available for WebPack. Won't be getting into all of them, but I'll be mentioning some of them later on. Cool. So where do we start? All assets are JavaScript. This minimizes the number of network requests drastically. It's great for mobile. You can inline your CSS and images in JavaScript. You can still load assets as separate files if desired. And once again, there's a plethora of different loaders and transforms for all the different options. So there's the Babel loader, and do you guys know about Babel? They just renamed it from 6 to 5 over to Babel.js, and kind of annoyed me actually because my business partner, the CEO, used to ask me, Taz, what are you working on? I'm like, I'm working 6 to 5. And he's like, you work from 6 to 5, and now I just say I work on Babel. He has no idea. So the Babel loader, there's less loader, there's JSX loader. I have a list of loaders over here to give you an idea. On the mobile mode. So you can get source maps, cowsay. You can embed a cowsay header if you want, so that gets back to the farm. CSV. You can. This is kind of cool actually. So this bundle can be used when you're loading in a bunch of different assets asynchronously. You can bundle them all together and send them over as one. SVG optimized loader, so you can optimize and press SVGs right in the build tool itself. You don't have to do a separate step for that. CoffeeScript, ES Next, Babel, LiveScript, SweetJS, all that fun stuff. All the templating engines you could think of, styling, translation, everything. It's all there. Cool, so what do I mean by this? So here's a few examples of how WebPack does this. Here's how we can insert CSS into the document globally. So here what I've done, I'm using the require syntax. I'm saying CSS loader and then load in this file. So that will then inject that into my HTML. This next one will actually optimize. So here we can see image optimization level 4. So I'm optimizing that PNG to optimization level 4, transforming that into a data URL, and then I can inline that in my JavaScript or my CSS as I desire. I can optimize SVGs equally as easily. This image loader is smart enough to know I'm loading in an SVG, so therefore optimize it. And here I can transform ES 2015 into ES 2009 by using Babel. So silly that they needed ES 2015, I mean. Okay. Code splitting, all right. So we only want to load the minimum number of assets required. So that keeps the initial payload small. You can load the rest asynchronously, and you can define code split points in your app. So React will use these split points in order to create chunk space in your dependency graph. And it's, they have a lot of different optimizations if you want to optimize for smaller initial payload chunks or fewer web requests, so therefore larger chunks, or if you want to optimize for smaller chunk sizes. And you can define multiple different entry points for your application. So if you have a few different pages that people are entering on, you can define those separate pages as different entry points, so that once again you're only loading the code required for that page. So here's an example of how we define a split point. We can use require.ensure syntax. I pass in module B. So what Webpack will do, it will load module B but won't evaluate it. And inside here, I have require module A. So now Webpack will know, okay, in this chunk, I'm going to group together module A and module B. I want to evaluate module A, but I don't want to evaluate module B. So in that case, Webpack is smart enough to determine module A is required in the callback and therefore load it, which is the opposite of AMD. So basically here, Webpack knows, okay, I'm using this inside my split. Therefore, I need to load this as well. While in AMD, I need to be, I need to define, I need to load that up front, and then re-require that in my function. So if I want to, require another module here, I can do require module C, and it just works, right? I don't have to put that in my loader up top. Similarly, I can just remove this entirely, and that works perfectly fine. It will group these two together as a chunk and will load that asynchronously as a chunk. This is the syntax that I usually use. I just usually don't define anything in my array. It's a bit odd to me to load a module but not evaluate it, so therefore I don't ever use that function. I just do this and it works. Cool. So code splitting gotchas. Okay. CSS relies on global state. Hub CSS. If CSS is managed by Webpack, and loaded asynchronously, depending on which pages you visit, what happens? So I have Canadian style sheets here, actually, not cascading. So in chunk 1, I have background color. Notice the U, spelled it correctly. It's maple. In chunk 2, I have my background color. Again, spelled correctly here. It's salmon. Okay, so scenario 1. Chunk 1 loads, and then chunk 2 loads. The background color is going to be salmon, right? Because like it relies on that global state of CSS to say, okay, maple was loaded first, and salmon was loaded next. Therefore, salmon overrides maple, right? What happens in the other scenario where chunk 2 loads first and then chunk 1 loads? It's the opposite, right? So this global state of CSS was really great in its inception, but when we're trying to manage very large JavaScript applications like we are today, trying to load code asynchronously like this can cause issues. So yeah, you can use the sorry if you're using Canadian style sheets, or the important if you're using CSS operator to set precedents. It's not recommended. I recommend just being a bit more specific about your selectors, so saying body.maple or body.salmon, and setting the class in your JavaScript. Because then obviously your JavaScript knows what page you're on, your JavaScript is able to manage that for you. Don't leave it up to CSS, leave it up to JavaScript. We're actually working on a commit to Canadian style sheets to make sorry a thing. You can come up to one of our hack nights and
works nice.
Cool. So that's basically the essence of WebPack. You're inlining everything as JavaScript. You're passing everything around as JavaScript. You're bringing in your CSS and your images. Everything is JavaScript, and you're loading it as one web request. It's more optimized for mobile. If you so desire, you can chunk things out in a more traditional way, where you have your a CSS file and an image file for all you old people out there. But anyway, I'm going to talk about a few cool WebPack tools. So I have links to these over here. There's a WebPack dev server. Sorry, dev middleware. It's a middleware that you can use on your Node Express app, and what this does is it will block the asset request while compilation is happening, so you don't have to like refresh your page and then it's broken because the compilation is happening, and then re-refresh it, and all that garbage. You can just block, and then it'll just happen when it'll just load when your compilation is done. And this plugs in directly into something like Express. You can say just app.use, and bam, it's there. Next up is the WebPack dev server. So it's basically the same thing, but it's just all bundled up for you, and it just has better integration with Webpack itself. The fourth thing I want to mention is React Hot Loader. So this is one of the coolest things I have seen in my web development career. It's mind-blowing. So what this is down here, they have a React component. So they have a React component defined here, best JS libs, and the actual component is defined inside here. For those of you that aren't familiar with React, React has this state that manages the internal component state. And if you've ever used something like live reload in the past, you know that once you save your file, it will reload that entire page, and you're basically starting out from fresh. What React Hot Loader will do is it will save that state and transfer that state over to your new component. So you haven't actually lost anything. You're just working with new code. And it will do this on the fly on a per module basis. So that is a huge development boon for me, and I've never seen something like this before. So they have a little example over here. So I can type into search. Let's say I'm looking for the lol.js library, and it's not there, of course, because it's not defined in my best JS libs. I can go up here and say backbone.js and lol, and bam, there it is, right? So what happened was that LOL that I typed in the search bar, that's set into component state. I've just redefined my code. React Hot Loader has taken my component state, transferred it over to the new code from the new component module, and everything just works. So in development, this is amazing. I can just develop very naturally, just save my one single module very naturally, and everything just works. touch options similar to Browserify, React Hot Loader, and then can integrate nicely into existing tools such as Grunt, Gulp, Karma, Bower, if you want to use that, etc. So we'll talk about this comparison here. So this is a comparison between all the different build tools, so WebPack, JS Browserify, and JS NPM. It's basically your feature sheet that you have for your startup, where all your startup is all checked off, but everyone else, our competitors, aren't. It's the same with WebPack, so you can see yes, 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 all the way down.
With manual configuration.
Source maps, plugins, everything. And this was kind of cool, actually. The runtime overhead was the least out of any other competitor. So it's kind of surprising. Require.js takes up 14.7K. WebPack takes up 243 bytes. So it's pretty awesome. Cool. So at this point, you're probably thinking, WebPack looks cool, but it also looks like it does everything under the sun. I'm kind of intimidated. Where do I even start? And what I've actually done is I've taken some of our code out of our own Webpack config because I want to show you what this looks like in production. I haven't really found any good examples out there, and I just thought, hey, I'll just go grab it from our code. Why not? It's config. It's not business logic. So anyway, here's our actual config, and it still has comments and everything. It's literally grabs straight out of the source code. So this is calling WebPack.js. I'm grabbing WebPack, grabbing my path, grabbing my file system. These are my different entry points. So here we basically load client.js. That is our entry load point. Unsupported is for unsupported clients. So we don't support IE 9 and down. We only support IE 10 and 11. So for any of those clients, we loaded this entry point. So we have two main entry points for our app. That's how you would define it. You can define a single entry point just by doing something like that, or you can define a single entry point with, that requires a few modules, like that. So just depending on the data structure you pass into that, it will determine. If you pass in a JavaScript object like I have, it will take that into consideration as multiple entry points, using the name as the name of the entry point. I want the output to be in my build directory. Being served on the public path. Public, that's where my express static server is pointing to. The file name. So this is kind of cool. The name here will be the name of my entry point. So that'll be like client or unsupported, depending on the entry point I want. The chunk hash. So that was where the checksum in Rails, or the checksum in most other build tools now, that's where that will get inserted. And the really cool thing about this or Webpack is that it's on a per chunk basis, right? So if you have a chunk that never changes, you never have to reload that to the browser. If you have a large file that has a checksum and that checksum changes, you're downloading that entire file again, right? Here you're only reloading the chunks that have changed, the chunks where the checksum has changed, right? So that was really cool. And basically the same thing for my chunk file. So this is the entry point file name. That's the chunk file name. I want to resolve these extensions. So that basically just means that instead of typing in like require something.js, I can just do require something. I don't want to be passing JS all the time. Now for the cool stuff, the loaders. So we're using React, the Flux architecture. So what I've done is I basically said everything is JSX, which was because the JSX loader has this Harmony option, which basically makes everything ES6. So I can write ES6 across the app, and JS transform will take in all that ES6, convert it back to ES 2009, and convert all the JSX as well. So we're using less. So what I've done is I'm passing things through the less loader first. That will convert less down to CSS. CSS loader will inline that and inject it into the HTML. Style loader, I believe that makes it possible to require assets from your CSS, and it will like if I was to require an image, for example, if I was to do require URL and then some image.png. If I did that in CSS, so I say background native style or image, right? That would work. That would then Webpack would then convert that into a data URL and inline that directly into my CSS. That's what style loader does, I believe. I could be wrong with that. But anyway, that's how it works in my CSS.
That's what it ought to do.
That's what it ought to do.
Yeah.
WAF files. So I started out with this. So that was trying to, inline everything. Where I inlined, it was a MIME type font WAF, bringing them as data URL. I took a step back with that, and I'm just loading it as a traditional file now. So you can still, load things as files if you want. Same with TTF, same with EOT. SVG, we're loading that in as files. What I actually do, because we're using React, is I transform SVG into a React component using JSX. Since JSX is basically an XML to React converter, I'm just converting my SVG into React and just loading it through React. But if I'm loading in, so in that case, I'll have like a .svg.js extension, and that will get picked up by my JSX loader above. But if I do have a plain old simple SVG that I want to load as a file, then I can do that as well. I can also specify a limit on my data URI. So if my data URI hits that limit, it will then back up and then load it as a file as well. So lastly, in terms of my plugins, I have this one plugin here. So what this will do is it will take the Webpack's build statistics and then save that as a file, so that I know like the actual entry chunks and what they're called. As I mentioned above here, my the actual file names change based on this chunk hash, right? So I know that it's called my client chunk, but I don't know what the file is physically called, so I don't know what to put in my script src. So once I get these stats down here, that will tell me what that file is physically called, so I can actually load it. Optimize occurrence order. That optimizes the occurrence order of the modules themselves so that the chunk hashes stay consistent. That was a gotcha, so I recommend using that line. And it's funny actually. So Webpack, the way that I heard about it was through the Instagram guys. They're using Webpack quite extensively on Instagram, and when they were looking at different build tools, they said we want these properties of our build tools. We want as few web requests as possible. We want async loading. We want transformations. We want all these things. Is anyone doing this? And they actually found Webpack, and they sort of brought it into light. They sort of brought it into popularity. The guy that actually builds Webpack, he doesn't speak English very well, I found. So there's a few instances where he spells things wrong. So for example, he actually spelled occurrence with only one R for a long time. And so it's sort of that the HTTP refer header, where the refer only has one R, but HTTP, if you were to spell refer, it actually has two R's in it, and it's a big headache if you've ever done anything low level with HTTP. Same thing happened here, but anyway, just something to watch out for. If something's not working 100%, make sure you look at the spelling twice and copy and paste it out of the docs instead of just going by the English dictionary. So this is our development Webpack config. So I'm just grabbing the config I defined before, tacking on dev is true, and then in my production Webpack config, I'm doing the same thing. I'm grabbing my common config and I'm saying dev is false. I'm uglifying it. I'm deduping things. I'm saying my minimum chunk size is 248. I think that's bytes or kilobytes. I forget. Defining node end and so on and so forth. So the important thing here is this: if dev is false, in combination with uglify, is kind of cool actually. So if I do if dev, and then I say console.log, hey, right? In development, that'll be if true, right? And then in production, that'll be false. So what uglifier will do is it will see if false. It will see that bit of code never gets reached, and it will completely remove that. So any sort of developer logging that you have, any sort of console log messages that you have in your app, you can use a similar technique of defining that variable and then leave it up to Uglify or leave it up to your minifiers in order to just get rid of it.
Will it also optimize at the if true?
Will also, yes, it will also optimize out the if true. Yeah. It sees that as redundant, so Uglify will actually remove that. It can do some more. Uglify can do some more advanced evaluations and stuff. So if you have like time equals like 60 times 60 times 60, it will calculate that for you and minify that for you. So Uglify has like a few kind of cool evaluations and stuff built into it to give you the smallest file size possible. And really, that's what I wanted to talk about. So thanks. Posting this online, so you can refer to it. But if you have any questions, I'm happy to answer.
Yeah, you mentioned at the beginning that you prefer CommonJS. I just wanted to hear your thoughts on why.
Why do I prefer CommonJS? So it really goes back to the way that you define modules using AMD. So scroll up here. Where was it? There we go. So this is how you define an AMD, right? That can become quite messy. The way that you do that in CommonJS is var a equals var a, and then so on and so forth, right? Var a b c d e f g h, right? So you just define them individually, and it's just a bit easier to keep track of what's being required and where in that way. Like AMD, it's a bit more concise, but I find you can sort of trip over it over time, especially at scale. So that's really my main, mainly why I like it better. There's also ES6 modules, and that's also cool. You can configure that to work if you use Babel and Webpack. I just haven't configured it yet.
You still wind up wrapping each page where you're using the style in like Nifty, as in the font.
I'm sorry, I didn't hear you.
Well, if you have a JavaScript file, you want to have closures to avoid losing full namespace. So when you use the CommonJS style, you still put like the SQL function around it, so that.
Well, so it's actually Webpack that does it for you.
Does it on your path?
Yeah. So Webpack will, it'll create a closure around everything, around the entire chunk, and then it will, and then it will load in each module and then refer back to the Webpack central module table. Any other questions? Awesome. Thanks so much, guys.